Hi everybody, I wanted to try something a little new this week and add a summary video to the end of the week, just kind of real life examples of how we can apply some of the concepts we've learned. So this week, of course, we've been talking about the macromolecules, so DNA, RNA, proteins, and carbs. So I wanted to bring you into my kitchen and go through some different product labels and see what we can learn from our product labels. All right, so I'm gonna switch you around here, going into my pantry here, looking at a few different things. So I'm just gonna pick out a couple. So our first one here we're gonna pull out our pasta here, and if we go to the back or the side and look at the nutrition facts, I'm gonna highlight a few things. So first of all, we look at the fats. So remember, we need our fats to store energy, but also to make those membranes. We'll be learning more about those next week. But there are different types of fats. We have triglycerides, and then those are made up of fatty acids. So on the label, they're just called fats. So we see saturated fat here, trans fat. Then we also see polyunsaturated and monounsaturated. So this is a nice example here of some of those different fats. So if you remember, saturated, they're surrounded by those hydrogens. They don't form double bonds, so they don't kink. And that's what we make as animals, but our plants typically don't make those. They are more unsaturated fats. So you can actually see here in the pasta, there's actually only 1 gram of fat, and it's not really made up of any of these things that are listed. But trans fats, those are the ones we want to avoid. Those are the worst for us, because they have that double covalent bond like our unsaturated, but they don't form a kink. So they behave like those saturated, where they're clumping together and packing. So we want to stay away from those. Then poly and monounsaturated, didn't really talk about these, but poly, of course, means many. That means they have lots or multiple double covalent bonds. So they can form quite a few little kinks in their tail, whereas monounsaturated, they have a single double covalent bond, so 1 kink in their tail. Of course, our cholesterol, that also helps in the membrane, helps to form a hinge. A little bit's a good thing, but too much hardens those arteries. But then we get down to carbs. That's what you see here. Let me zoom in. So carbohydrates, so this pasta has 41 grams of carbs for each 2/3 cup. So some of that dietary fiber, that's mainly our cellulose. Remember, we don't have enzymes to break cellulose down, so it's going to go through undigested, and if we eat too much of that, too much fiber, then those bacteria start breaking it down and can cause some gas and bloating, some discomfort there. Our sugars, so sugars here is applying to some of those simple, so like our disaccharides or just plain glucose here. So none of that's really stored in here, because most of our carbs are really going to come from starch, okay? Because that's the storage form of all that glucose made in photosynthesis that those plants are making, that are used to make our pastas. And we can see a little bit of protein also found here in our pasta. And of course, proteins are made up of amino acids, and those have that specific structure that determines their function. So that's our pasta, lots of carbs there. Speaking of those simple sugars, let's see what else. So we have some evaporated milk. So if we look at our milk, of course, hopefully you can think whenever milk, as far as carbs, that's going to be lactose. So if we look here, now we have some sugars. So total sugars there is 3 grams. That would refer to that lactose that's in there. Also here we can see some fat in our milk, so 2 grams of fat. Most of it is saturated, because animals, like our cows, we make saturated fatty acids. Plants and fish, they make the unsaturated. But also, thankfully, no trans fats are added. Of course, hydrogenated and trans fats, those are artificial, so those would be added to things to increase their life, like shelf life on there. But also here, thinking about some proteins, I've enlisted the help of my daughter here, Elizabeth. You want to say hi? Hi, Elizabeth. What are you doing?
I'm getting ready to fry an egg.
You're going to fry an egg? Well, you know what? That's a great example of when proteins denature. So you go ahead. Let's kind of demonstrate this here. Try not to get any shell in it. Ooh, look at that. So right away, we see, what color was that whenever it started?
Clear.
Yeah, it was clear. Well, what happened to it?
It turned white.
That's
because
right.
the pan was hot.
You're right. It was because of
You
that.
can see right there, it's still a little clear.
Oh, yeah. I see that.
Right around the yolk.
Would we want to eat it like that?
No.
Oh, no, that doesn't sound good. All right, so you know what's happening here? Proteins are becoming denatured.
What now?
Well, when proteins denature, they lose their shape. So the protein in the egg, when it was cold, they were nice and clear. Well, whenever we heat them up, they lose their shape, because shape of proteins is really important. So you know what else? The proteins, whenever we heat them up there and they become all solid like that and white, you know what? They wouldn't work anymore. Whatever they were doing before for that little egg and chicken, they're not going to do it anymore because they're denatured. All right, guys. Well, like I said, just a little summary looking at our macromolecules. Of course, DNA is not really something we see in our protein or in our nutritional facts, but that DNA is really important for heredity and passing on that genetic information. All right, well, you guys have a great day, and we'll see you next week.